Hi friends, welcome back. Today we're talking about the interior angles of a polygon. Super excited to do this. There are a lot of great notes, so you are going to want to grab your notebook. And when I say write something down, please write it down. Oh my goodness, it will help you in the future. Okay, so with that in mind, interior angles of a polygon. All right, we're going to talk about a triangle. We've got a triangle here. A drawing of a triangle, that's what it looks like. It's got 3 sides, and the number of triangles within our triangle, it's just 1. That'll make a little bit more sense in a second. Remember, there's 180 degrees in a triangle, so that's going to be relevant here. Let's take a look at the next sided figure. So we have 3 sides on this one, so our next figure is a 4-sided figure, and we call those quadrilaterals. There are different types of quadrilaterals, and we'll dive a little deeper into those later on in this unit. However, right now I've just drawn a parallelogram here. It's just a 4-sided figure. That's all a quadrilateral is. Now, so the number of sides here, we have 1, 2, 3, 4 sides. How many triangles are there? There are 2, and remember, every triangle has 180 degrees. Let me show you what I mean by 2 triangles. Kablam! There are 2 triangles there. All right. Number of sides, 5-sided figure. Let's see if we can do that. So for a 5-sided figure, we have a pentagon. Oh, I should back up and say, if there are 2 triangles and each triangle is worth 180 degrees, we have 360 degrees in a 4-sided figure. So a pentagon, that is a 5-sided figure. Now, how many triangles can we draw? We can draw 3 of them. Go like this, and then again like this. And that's kind of hard to see, so maybe I should use some pen. All right, so if we draw like this, and then again like that, you can see that there are 3 triangles in our pentagon, and 180 degrees times 3, we get 540 degrees. You had better be writing this down. Next is a hexagon. Hexagon is a 6-sided figure, Now, with that 6 sides, you can draw 4 triangles. Let me demonstrate that for you. We've got this guy. So we got 1, 2, 3, 4 triangles in our hexagon, which means we have 720 degrees because each triangle, again, is worth 180 degrees. All right, let's talk about our next one. Heptagon and octagon. No, I'm not drawing those. You can barely draw a hexagon. Been doing this 20 years, still can't draw it. But we do know that a heptagon has 7 sides, and if we did draw that out, we would have 5 triangles, which is 900 degrees. Octagon, 8 sides, 6, and you can see that for a nonagon, a decagon. Okay, so what we're looking for here is a pattern, and I bet if you look at these numbers, you'll see that for the number of sides that we have, if we take away 2, that's how many triangles there are in that figure. Knowing this information, we are able to figure out the number of degrees that are inside that polygon. So let's talk about that. Grab your notebook if you hadn't already, because these are going to be some important formulas for you. Okay, so the important formulas, let's take a look at that. Important formulas, what we have for our first one is, as I said, the sum of the interior angles. Remember, sum means addition, right? So if we add up all the interior angles, the way we do that is we take the number of sides, we minus 2, and then we times it by 180. So the way that formula looks is the sum of the interior angles equals 180 and then quantity or parentheses n minus 2. N means the number of sides. Take the number of sides, minus 2, multiply it by 180. Okay, here's where it gets a little tricky. What if I asked you to find the interior angles, the sum of them, but I wanted you to find actually just one angle inside that polygon? This is what that formula looks like. We have the measure of an individual angle in a polygon. Let's try that. Ooh, I fixed that nicely. Find the sum, then divide by the total number of sides, which we use n for to represent. So we add up we figure out how many degrees are in the entire polygon, the sum, right? And then we divide it by the number of sides, because that's the number of angles that we have. And if this sounds confusing, totally understand. We're going to do some examples so that you can see how this works. Okay, so just in case you didn't get that from the previous one, oh, that's really not that dark. I'm very sorry about that. This is from our previous table. It's just the types of number of sides and then the types of or the name of the polygon that we have. Okay, so pause the video, write that down if you need to. All right, for our next spot, we are going to do some practice problems. Okay, so for our first practice problem, I'm sorry, my microphone's right there as I'm like shuffling papers. That's not very nice. Okay, so interior angles of polygons. What is the sum of the measures of the interior angles of a heptagon? Okay, so the sum means we're going to be adding them all up. So this is that lovely formula where we take the number of sides and we minus 2. So we're going to have 180 degrees and then the number of sides. Now remember that a heptagon is a 7-sided figure. So we're going to take 7 and minus 2 is going to equal our total degrees. Well, 7 minus 2 is 5. So we have 180 times 5, which gives us 900 degrees. So if you add up all the angles inside a heptagon, you are going to have 900 degrees. All right, let's try example number 2 here. We have, what is the measure of each interior angle of a regular hexagon? Okay, what is the measure of each interior angle of a regular hexagon? Well, we remember that a hexagon is a 6-sided figure. So we say, okay, 180, and then we take 6 minus the minus 2, so the number of sides minus 2, and that is going to give us 180 times 4, which we get 720. So 180 is 180, and then we have 4 triangles, that's 720. Now, is that the final answer? Absolutely not. Go back, read the question. It says, what is the measure of each being the key here, each interior angle? So this is the sum of those angles. So in order to find each, we have to take 720, my pen is not cooperating, and we have to divide that by the number of sides because that's how many angles are in a hexagon. So if we divide that by 6, because there are 6 sides in a hexagon, we end up with 120 degrees. So every angle in the hexagon is 120 degrees. Okay, next one. Let's see what we got here. One interior, oh, you can always see when I mess up. It's way clearer here than it is on the paper. One interior angle of a regular polygon measures 144 degrees. How many sides does that polygon have? Whew, okay, well, let's go back to our formulas. We know that if we take the number of sides, which is what we're looking for in this case, if we minus 2 and then whatever that number is, we multiply it by 180. So 180, number of sides minus 2. That will give us the sum of the total angles, but we don't have the sum. What we have is each individual angle. And so we're going to need to take whatever that is and divide it by the number of sides. And that will give us each individual angle. And if you recall, that is this formula right here in pink. 180 n minus 2 divided by n. That'll give us each individual angle, which we know in this case is 144 degrees. So we're going to set that equal to 144 degrees. So you might be looking at this and saying, I have no idea how to solve this equation. This looks a little crazy. A couple different ways to solve it. First thing I would do is I want to get these ends together, but I want to undo this division bar here because that'll help. Division means fractions, and fractions can be a bit of a pain. So we are going to multiply both sides by n, because if I do that, I can cancel it out on this side. And if I cancel it out on one side, that makes it a little bit easier because now I don't have a fraction. So let me slide this down so you can see better. We now have 180 and quantity n minus 2 equals 144n. All right, from here, we're gonna just distribute 100n minus 360 equals 144n. Okay, at this point, we need to combine like terms. So I'm gonna move my 180n over to the other side by minusing it from both sides. Good, and so at this point, what we can do is cancel these out. So what we're left with is, I'm gonna write, so negative 360 equals 144 minus 180 is gonna give me negative 36n. Let me rewrite that over here. I didn't leave myself enough room. Negative 360 equals negative 36n. To get that n by itself, oh, it helps if my face is out of the way, I'm sure. To get that n by itself, we're going to divide both sides by negative 36. And these cancel out, and we're left with positive 10 equals n. And remember, n represents the number of sides. So how many sides does this polygon have? This polygon has 10 sides. Hope this helps. I look forward to seeing you in our next video.